Hello, my friends. This is Elohe Amini. I passed SPI Physics. My score is 690 from 700. So I decided to share many important SPI questions. This time about frame rate with temporal resolution. The first question, when should we care about frame rate and temporal resolution? Static imaging, moving structures, both, none of them. Moving structures. It is like a movie. For watching all parts of the moving actresses or actors, we should have the image of every moment of their moving, like fast moving valve leaflets of the heart. What is the unit of temporal resolution? Hertz, millimeters, seconds, unitless. Hertz. Temporal resolution is determined by frame rate and both have the same units. It is very important per second or hertz. The number, it is the number per second, not second. Assume that there are 30 frames each second and each frame has 100 lines or pulses. Hence, PRF is 3,300, 1/30, 30,000. Yes, 3,000. 100 lines for every frame. We have 30 frames, so 100 times 30 equals 300. One of the formula for partial repetition frequency is the number of lines per each frame times number of frames per each second. This may be help to imagine each frame rate with 100 lines and all of them in 1 second is TRF. That is related to depth. Here, pulses are the same as their lines because each line has one pulse and one focus, like this small pulse. When frame rate is 30 hertz, what does it mean? Yes, both A and C. I will explain the fields means when each fields from odds and even together makes one frame. So the number of frame is half of the number of fields. When you change the depth by turning depth button, you change all of the following except. Please do the physics learning with machine. It helps you a lot. Imagine you are turning increasing or decreasing depth. Which of them does not change? Frame rate, pulse duration, PRF, PRP? Yes, it is pulse duration. Only manufacturer can change pulse duration in one transducer. It is not adjustable. Pulse duration equals number of pulses times period. Period is time. So pulse duration is time also. No one can change that. It doesn't relate to frame rate or temporal resolution. Shorter pulse duration, better axial resolution. Shorter pulse is better for imaging. With changing depth, you are changing 5 items. Please remember, frame rate. Every time you speak about frame rate, follow with temporal resolution. They are the same. Pulse repetition frequency, if you increase depth, you decrease PRF. And if you increase depth, decrease PRF, and also it is about duty factor. You see here, duty factor. So increase depth, decrease PRF, decrease depth, increase PRF. So decreasing depth, increasing PRF, and improve frame rate and temporal resolution. But when you increase depth, you increase pulse repetition period. And the duty factor will change. When you increase the depth, duty factor decreases, because duty factor equals pulse duration divided by pulse repetition period. When the frame rate is 30 hertz, 30 images per second, what is the time for each frame? 1/3 second, 30 seconds, 3 seconds, 1/3 second. The first one is 1/30. Please think about it. Yes, 1/30. Maybe you think that why all the questions are 30 hertz, because it is a standard rate of frame or temporal resolution. You are scanning fetal hearts with the M mode, which for it, the ultrasound system creates each image about 0.01 seconds. What is the frame rate, number of images per each scan, each second? 100 hertz, 1 kilohertz, or 1000 hertz? 100 seconds, 20 hertz. Remember this time for 1. So in 1 second, yes, 100. Each second is 100 times of the 0.01 seconds. So the machine can create 100 frames per second. Which one has the worst temporal resolution? Right magnification, read magnification, A mode, color Doppler. Instead of A mode, we can tell M mode, no matter. Color Doppler has the poorest temporal resolution. Why? Because for each scan line, color Doppler has 5 to 30 pulses per each line. So many times to take one image. So low frame rate, low temporal resolution for color Doppler. But M mode, you look at this image, M mode is one-dimensional, only one line for each image. So it takes a very short time to take one image, and it has very high frame rate and temporal resolution. During zoom reading or reading magnification, what happens to temporal resolution? Improved, degraded, unchanged, all. For reading magnification. Yes, unchanged. Reading magnification or zoom reading, the button of zoom, you increase the size. You don't have the patient. So you use the previous images and you increase the size of the image or zone of region of interest, and the size of the pixels increased, but the number of the same. So pixel density decreases, and it doesn't change the temporal resolution and spatial resolution, but it has less line density. Name all items that their units is hertz per second. or per second. You look at here, please, per second, not second, per second. Maybe this comes in SPI, maybe this one or this one. Frame rate, temporal resolution, reflected frequency and resonant frequency, pulse repetition frequency and Nyquist limit, Doppler shift, all are connected each period of time like per second. Yes, all of them has the unit of hertz, but resonant frequency and reflected frequency are very large, megahertz, million hertz, and others like frame rate, temporal resolution, and PRF, pulse repetition frequency, and Nyquist limit, only hertz. For typical value of pulse repetition frequency, it is 1 kilohertz to 10 kilohertz. Remember, resonant frequency is the center frequency or fundamental frequency, and we put these two together, remember, in Doppler, and this together for example, PRF and Nyquist, because PRF is 2 times of Nyquist limit, or Nyquist is half of PRF, it helps you to repeat them. Why does color Doppler have the worst temporal resolution with the lowest frame rate? Please read. Yes. It has many pulses per each scan line. Of each image, 5 to 30 pulses for each scan line or ensemble length. When we have Doppler, color Doppler, we tell ensemble length. Otherwise, the number of focuses is the pulses per each scan line. See here, lowest frame rate. For the option B, lower depth is shallow imaging, so it increased and improved temporal resolution. C, less line density per each degree improves. And increased frame rate is not correct because the question is with lowest frame rate. So color Doppler has many pulses and many times create one. If the frame rate is 30 images per second and each frame or image has 100 lines, then pulse repetition frequency is, yes, 3000. Okay, my dear friends, I will send it the next part of frame rate. I have many other questions. I hope this video helps you. Thank you for your patience.